I do want to start by thanking the Military Cyber Professional Association for having us this morning. It's an honor. This is our third year participating in the Pavilion, and it's awesome to see how it's progressed from year to year. The plan today is to give a brief introduction on who Jericho Systems is, and then I'm going to walk through what authorization is and what it's not, and the evolution of next-generation access control. Then Gene is going to come up and talk about artificial intelligence, and we're going to finish with a short demonstration to give you a picture of how it relates to a real-life use case. All right, about Jericho Systems. Who are we? We're a small, certified, woman-owned business headquartered in Dallas, Texas, although we do have primarily a remote workforce. We were launched and incorporated in 2002, and we've been certified and accredited on most, if not all, classified networks. We've done nationwide implementations ranging from showcases and demonstrations all the way to massive deployments. We are 100% made in America. We're proud to be from Texas. And again, it's an honor to represent the Army today. We've done quite a bit of work across the Department of Defense over the past 15 years. Our largest client is Tactical Army. We're very entrenched in the intelligence branch as well. And we've done, as I said, large deployments protecting data up to millions and millions of records. We're also heavily involved in healthcare, and we've done a lot of work authoring international standards in privacy and security, specifically with patient consent. The idea that you should be able to delegate who views your medical record, and not just who views it, but what elements within your record should be released. For example, if you have a sensitive HIV, substance abuse, some type of information that you don't want a provider or an outside requester seeing, we can actually strip that out of the medical record so that it's not seen by them. And this is based on privacy laws. And we've done a lot of work helping author those standards with HL7 and some of the other standards bodies. We're a proud partner of the University of Texas at Austin's Health IT program, of which I'm a graduate. And we have a large deployment with a large managed care organization on the West Coast. I do want to mention we've also done quite a bit of work for 9 years working on privacy and security with the Veterans Administration, specifically with VLER, which is the Virtual Lifetime Electronic Record Program, dictating the access of medical records for veterans' clinical data. So what is access control? Access control 101. There are 3 components to an access control system. You have authentication, authorization, and auditing. Most people confuse authentication and authorization because they think they're the same thing, but they're not. Authentication is me proving who I am to a system or to a group. You can think of using an ID or a CAC, a common access card, or a username and password to identify who you are. But authorization is actually the next step. You're saying, what can I do with these credentials once I've shown who I am? Once that happens, then there's auditing, where you're actually monitoring the records of your usage or what you've been doing to track what's happening within the system. The best example that I can think of in real life would be a gym membership. When you go to the gym and you present your ID to the counter, you're authenticating because you're proving who you are, where you're from, so that they have some of that demographic information. But you may not be authorized to go into each room within the gym. For example, you might go to the weight room, you might be able to lift weights, you might go to the basketball court, be able to shoot hoops, but you may not be authorized to go into the sauna because your membership isn't at that specific tier, and you'd have to actually upgrade in order to go there. So while you have access to the building, not every part of the building is allowable for you to go. You can think of the same type of concept with IT systems. You have applications, databases, systems, electronic records. We're primarily going to be talking about logical resources, not necessarily buildings or physical access control. And why is this relevant? Well, number one, the big word that everyone's using right now is compliance. If you're in healthcare, you have HIPAA obligations you need to meet. If you're in finance, Sarbanes-Oxley, commonly known as SOX. There are also quite a few safeguards within the government for sharing classified information. And not only that, as you can see from the screen, and it is kind of a pain point for some people, there are many different breaches that are happening from month to month. And this is only one slide. I could have named many other slides. There are probably a few other companies that come to mind. And many people's data, I'm sure in this crowd, you may have been affected by OPM. There were nearly 22 million records exposed. I was even reading in 2014, 2 healthcare organizations were fined $5 million for breaches. So as you can see, this is a problem, and we're still evolving, we're still learning. And part of the issue that we see is that a lot of the access control paradigm is around the network layer. So can I get into the network or can I not? It's an all in or all out. there's a big focus on the perimeter defense with next generation firewalls, intrusion detection, intrusion prevention. And while that's great, there needs to be a layered approach to security, a defense in-depth approach. And that's why we're going to be talking about authorization, specifically next generation authorization. The other thing I want to mention is that our clinical data is worth a lot of money. Our PII, if it's sold on the black market, there's a reason why there's so many hacks and there's so many breaches happening. So we all have a vested interest in this, whether it's the consumer, the business, or the government. So that brings me to my next point, which is role-based access control. This is a very common access control model, and commonly what happens, as you can tell by the name, is you map functions to roles. And based on your specific function that's tied to that role, you can perform actions within your company. One of the common ways that companies use RBAC, or role-based access control, is by grouping roles together. So you can see I have group 1, group 2, group 3. Group 1 can perform a certain set of actions. Group 2 can perform a different set of actions, and so on with each group. And while this may seem like a very simple, rational way to solve a problem with different users, it doesn't scale very well. You can imagine how much role engineering it requires when you have millions of users or thousands of users with multiple roles, multiple personas. It's very difficult to scale. It requires a ton of mapping. It's resource intensive. It's very costly. And there's a number of different administrators that have to oversee that task and then re-engineer roles when a user is moved from project to project. It can become quite a headache. Next slide, please. Which leads me to role explosion. What is role explosion? Role explosion happens when you have to create a new role for every set of circumstances that arises. So you, as I said earlier, you have to re-engineer roles and map them to every particular permission that you can think of. And this leads me to the next problem with RBAC, which is that it doesn't account for dynamic changes in the environment. Your location can change from second to second. The time of day obviously can change, and other factors such as the threat level. It doesn't really fit well when you're trying to account for the interconnected world that we live in, where there's your friend becomes your enemy from second to second, and you have to constantly be evolving and changing. Thankfully, though, many people are having a light bulb moment. Yeah. I like to think of these kids as the next generation of CISOs and CISOs, and they've got their thinking caps on, and they're thinking about attribute-based access control, because this is the next generation of access control. And there's really been an uptick in the market with ABAC over the last 5 years. There's a NIST publication, 800-162, if you're interested in reading more about that. ABAC is much different than RBAC and overcomes many of the limitations that I mentioned earlier. And how does it do that? ABAC uses a high-speed rules engine that's making decisions based on policies. These access control policies are built by attributes. So your role is just one attribute about you. Who are you? What are you requesting? Why are you requesting it? And even how are you requesting it? You can incorporate each one of these attributes into a policy, and you can cover much more ground than you could with older access control models. And not only that, you can actually get pinpointed and very specific with the resource. You're looking at this screen right here. I could allow you in access to this specific slide or even to the words on the page. You can detail resources and get very fine-grained, if you will, with ABAC. And here's an example of some of the attributes that we're looking at when we're building these policies. For the requester, as I said, role is one attribute, but what is your clearance? What department are you from? How old are you? What's your job title? What type of action are you performing? Are you looking for a specific file? Well, what type of file is it? Is it classified? What's the sensitivity? And then also the context. ABAC is dynamic. It's very flexible. It overcomes some of those inherent limitations that RBAC had. So you can incorporate users can only access specific resources during working hours or from this specific IP address or when the threat level is at this level or the next level. Here's an example policy I wanted to kind of paint a picture of what I'm talking about. This policy says an administrator can view a certain file if within proper working hours and if their clearance is above secret. What I'm doing is I'm incorporating a number of different attributes into one policy to get much more specific than I could with some of the other models. I have two different subject attributes, so what is your role and what's your clearance? I have an action attribute, which is just a simple view or access. We have the resource, and then we're bringing in the context into the decision there. So you can pull from each one of these specific attribute buckets to create very complicated policies or simple policies. ABAC is standardized. It uses SAML and XACML. It's extensible access control markup language. But now, what comes after ABAC? What we're doing at Jericho with our product, which is entitled Interspace, is we're looking at adding a risk attribute into security decisions. And what risk does is it allows you to override the situation at hand and even the rule that you're looking at. So you can think of it as weighing the operational need versus the risk of allowing somebody into the system. So you could think if you're deployed in Afghanistan and you're part of a troop and you're under heavy fire and one of your users needs access to a top secret document and they only have a secret clearance, the operational need in that moment might outweigh the risk of denying them access to that document. So we're incorporating a risk attribute based on different factors that we know. Who is the user? Maybe how long have they been deployed? What group are they with? Where are they located? And we'll have Gene come up in just a second and talk about how we can create that risk score using a model service and pull that into the policy to then make a even extended decision using not just attributes that we know, but an attribute that we may not even know at the time of the request. Gene, do you want to come up?
It's hard to talk about artificial intelligence when you're not sure exactly who you're talking to. How many people are working with artificial intelligence right now?
We're some with cyber future requirements.
Cyber future?
So looking at Unified Quest in 2025 and 2030. They do talk about the need to integrate things like artificial intelligence to make us more with less, like be able to automate certain functions.
Excellent. Good. So we have some experience in the crowd. You just turn on the TV set and you hear AI, you hear machine learning, you hear a lot of words thrown around. You also see self-driving cars coming up. We see AI on our phones. My wife's computer recognizes her when she sits down in front of it. So we're dealing with AI all the time. There's no doubt that AI is going to be part of everything that we're doing in every business, every application. So at Jericho, what we thought about was, how do we apply AI to what we're doing in attribute-based access control? And the key is big data here, right? With the data that's been available in the past, rules have been sufficient for actually making decisions on authentication or authorization. But now that we have a lot of data on every person, it's difficult to actually come up with rules. It's difficult to have an expert say, out of these 1,000 attributes that I have on an individual or an entity, how do I assess the risk of that individual? What we decided to do is apply machine learning in a few different ways for access control. First, risk assessment. Instead of saying yes, you're authorized, or no, you're authorized, we're going to provide a probability of how much risk is in this individual. This person has a 65% likelihood of being a bad guy, or a 0% or a 10% chance of being a bad guy. So we can make a decision on that. We also want to deal with classifications, and we want to deal with unsupervised types of processes where we can actually look at mass amounts of people and classify them into different categories. So I thought maybe we might want to do more of an informative presentation to tell you how that's done with this presentation, so maybe you can add some knowledge to the actual buzzwords that you hear all the time. I'm not sure if you can read this back there, but this is the slide that's been used since neural computing and AI started back in the 90s. What Tyler was just talking about was attribute-based access control, which is a rule-based operation. You have policies, and within those policies you have rules, and based on the attributes that we see on each individual, we decide whether that person is authorized to see the information that they're asking for. What we're adding is the machine learning piece of this, and the machine learning piece of this is the ability to go into a vast amount of data and look at patterns in the data. And we usually look at it through a supervised or an unsupervised fashion. There's one thing about machine learning that we should probably set clear. When I was first asked to apply machine learning in this application and some other applications, folks said, well, once you develop a model and put this into place so it's providing probabilities, that model will continue to learn. And there's this idea that machine learning is this entity that you put out in the field and it continues to learn as the process is going. Not necessarily true. Okay, that's an aspiration for AI, but the technology that we have, the learning algorithms we have, aren't quite there yet. So what we have is an offline learning process and an online deployment process. We like using neural networks to look at different types of applications because neural networks have a high degree of flexibility. And so what we've done in the Interspace 9 product is we deployed automated machine learning, which produces neural networks. So I'm going to go through that process so you understand a little bit more about what we're doing. This is a diagram of a model. I wanted to bring this up, and I didn't want it to be too technical, but it gives you an idea of what a basic model looks like. In this particular situation, we're just building a model to predict the probability or chance of rain. Okay, this is sort of a good example we can all relate to. And what variables or attributes would we look at to predict whether it's going to rain or not? I have some of them listed below: temperature, the pressure, elevation, the month of the year, the humidity. A model takes that data and combines it with weighting factors that basically provide the importance of each one of those attributes. So W1 for temp, W2 for pressure, and it puts together basically a mathematical equation that we call a model. And once that model is put into place, we could use that to predict the probability of rain. So let's just talk about how that's done. Typically, when you're building a model, you're looking at historical data. So if I want to build a model that predicts rain, I'm going to go collect data for the last 2 or 3 years and whether it rained or not. And I'm going to collect those attributes for each one of those days because those are recorded. So I have, the pressure, the humidity, the month of the year. I have that data for each day over the last few years. I have the fact whether it rained or not. And since I have that fact, we call that supervised learning. We're going to build a model that and supervise it by telling it whether it rained or not, and that model is going to go through a process of adjusting those weights. Remember the weights on the one before? So it'll produce an output. There'll be an error produced. Say the model says it's going to rain, and it didn't rain that day. So it goes back and adjusts its weights, and that's the machine learning part. It adjusts those weights automatically through a learning algorithm. And if you look at machine learning and AI, it's loaded with different methods for learning. They call them learning algorithms. So we go through this process until we get to the point where the model is actually predicting the rain every day. Okay, now it may not be a yes or a no, it'll give you a probability of rain. So the final model, in this case, only uses temperature, barometric pressure, and humidity. So it's another part of machine learning that's very valuable because in big data, when you have thousands of variables, you may find that only a dozen of those variables or those attributes are important for a specific type of application for the model.
Does your model have the ability to identify other unknown variables before that? So, say, for example, the number of Canadian geese in the air, right, tended to indicate percentage of rain because geese were a good indicator for change of barometric pressure.
Right.
So now you've got a new variable that you wouldn't consider before.
Right. So if you have that variable, so the question is, can you consider?
Pick that up, or do you human have to pick that up?
We have to have the data for it. So the question was, if Canadian geese are flying north or south, could that be an indication? Well, if we have the data that says that during that day, Canadian geese were flying south, and other days they were flying north, then it could use that data if it's relevant and if it works. The key is having the data, and that's why machine learning has gotten so big lately, because we have a lot more data than we had 15 years ago, and there's data being collected on everything. So the idea is, and it's a good point as well, because that may come into play later. So we may develop a model initially, but say after the model is deployed, we find that we have that Canadian geese data, and so we reform a data set and spin that model again. And so what we've done at Jericho is we made it very easy to spin a model up and load it into the Interspace 9 process. And we could do that once a month, once every 6 months, or we could do it every hour. It really depends on how rapidly the data is changing that drives the model. So that's what we saw was a basic model more relevant to a regression model. Are we familiar with regression models, which have been done for years? They say machine learning is something new. It really isn't. We were developing regression models using machine learning ever since the PC came out, and before that, they were running regression models on mainframes. Okay, but when scientists and mathematicians started getting a desktop and they started being able to develop their own learning algorithms, they developed a lot of different types, more sophisticated types of learning algorithms that pick up not just basic linear relationships, but nonlinear relationships. And that means Canadian geese flying south could be important in predicting rain if you're close to the northern border of the United States, but it might not be important if you're down in Florida. Sometimes they're important, sometimes they're not. Well, that would be hard for a regression model to pick up, but I showed a couple of different topologies here. We've heard of neural networks, right? And so based on what I just showed you in the regression model, you can see the difference in a neural model where we have sort of a nested regression type of operation. There's a number of different models within a single model. And there's you may have heard of deep learning. Deep learning is another buzzword that you hear a lot about in AI. And deep learning is typically an advanced form of a neural network, usually a multiple layer neural network like you see in the far right. A couple of other topologies. Now, what we're using at Jericho with Interspace 9 is a neural network with cascaded deep learning. Now, it doesn't always look like that. Okay, this is just an example. Sometimes the model could be much simpler than what you see on the left there, and sometimes it could be much more complex. The system that we use, which is an automated form of machine learning, can build a neural network model up to 8 layers in a dimension and 2,000 nodes in a layer. So what you can see here with the cascade deep learning, you see basically 6 nodes that are separate models built within each other. We can build models that have up to 2,000 of those nodes in there. So we can get into very, very sophisticated, highly nonlinear types of predictions. And that's really based on the type of behavior or the problem we're trying to solve. The other example of the neural network I wanted to show you is the multiple output model. So we can build a model that basically classifies a person into a certain category. So we may look at all the attributes on a requester of information, and our model may come up with the most likely clearance level of that person based on the attributes that we have. Of course, they have their role, they have who they say they are, but then there's tons of other data that we have available to us that we can use. In other cases, we can use unsupervised learning, where we actually just look at the data and we classify the data into different clusters. And that's valuable for just when we're dealing with a lot of individuals, a lot of entities. We could run something like a model that looks at data and decides, hey, this is a non-human entity or this is a human entity. So we'd like to know whether it's a system requesting or whether it's a non-system request. And we want a model to actually tell us that. We don't want the entity to tell us that all the time. The models act as basically an advisor. We set up rules to listen to the model. We can set up rules to say if the model predicts at a certain level, we're going to allow or authorize, or we're not going to allow or authorize. So the model doesn't necessarily make the decision, the rule makes the decision. The model is a professional advisor to the situation. Sure, go ahead.
Did you have each of those nodes looking at different aspects of your network or your business? Say, for example, one node was using a model that looked specifically at individual user actions, whereas another node looked at activity at the subnet local area network level.
Right.
Another node focused at a wide area network. Another node focused on your business processes external. And those were able to communicate with each other and it provided overall risk rating for your network as a whole.
Well, okay, so the question is, can you direct certain nodes of the model to look at specific characteristics or facts or different areas of the problem? The thing is, with the machine learning processes, the idea, first off, is there's no expert that can say what you just said. In other words, you could put out the categories that you just talked about, but you can't really define how important each one of those categories are in each situation. So it's so instead of having an expert provide that, we have a learning algorithm go through the data and learn that. If you were able to say that this aspect should be looked at in this way and that aspect, then we would actually build rules around that, because we have an expert telling us exactly what to do. These models in machine learning are normally used when there's no expert that can actually pinpoint exactly what the parameters should be and what the answers should be.
Think back like a Home Depot attack, right? Right. When there was elements of individual user actions that led to the initial exploitation. There was then indications probably at the subnet, local level, right? And then that transferred to data moved laterally, so you saw a larger network issue, and ultimately it populated in the business side of their external facing part of that network. So if someone can give you appropriate user behavior, what the network needs to look like at that subnet level, how it will baseline.
Right.
Right? And you can put all that together at the people level to say, if you've just gone red, but all these 3 to 4 different areas are now reporting an issue.
Yeah, that's a good question. And it's actually a good example. The example was Home Depot breach. It's always helpful to be able to segment out the situation. So in other words, I'd rather build 5 models looking at different aspects of a situation and then combine those models and that output in through a rule or through another model. Okay, it's always better to segment if you can, and logically. The other thing about that is it's always, in these types of situations, it's important that we do real-time processing. In other words, running that model in real time and not basing the model output on data that was collected yesterday or the day before. Classic example, somebody tries to hit the network in the morning. We might provide them or deny them. They try to hit it again. They try to hit it again. That's information that we wouldn't have had if we ran these models offline. So running the models online, extremely important. So what we're going to do today, we thought maybe a little primer like you just got on models. We developed a model for a demonstration that Tyler's going to come up and do. This is the actual model, the graphical depiction of the model. This is a data set that's based individually. So we have a row of data for every individual that is authorized to actually make a request. I'm not sure if you can read this down on the bottom, but we have different attributes on the bottom that tell us things like what device they're using or where they're requesting the information from, what the threat level is in the environment, what branch, are they a temp employee, are they an FTE, have they missed work lately, what's the length of employment. These are just some example attributes that we would have on somebody. So we built a model that actually used that data. And when we built the model, we used automated machine learning to do this. I won't go into what that is, but maybe we can do that offline. And what it came up with is a neural network that has 7 hidden neurons in the network. And this is actually part of the automated process. It determines how many you should have. And it determines if to reduce it, to make a simpler model. Like I said, it can have up to 2,000 neurons in that architecture. And we trained this model, and then what we did is we transferred this model into Interspace 9. Tyler is going to come up and show you how that model was used in a real environment, like on a website. You ready? All right.
So we actually have 2 videos for you. The first one is going to show attribute-based access control, and we'll build on it in the second video. Both of them will take about 10 minutes. The first one's roughly 6 minutes. So we're going to be looking at access to just your traditional web portal. And we built this demo as part of a proof of concept for a large transportation company. So some of the terminology revolves around a railroad and rail traffic with cars. I have 4 different users for the demo. I'm going to be looking at 2 of them, and they're going to be logging in. It's kind of difficult to see using a PKI certificate. So up there at the top, you have Jim Russell. He's the first user, and he's going to be authenticating. You could think of using his CAC. And what we're going to do is we're going to present a page to him, and we're going to secure and personalize the page based on his attributes. So you could think of him coming in Monday morning at 8 a.m., and he's looking at his portal. He logs in, and these are the widgets and the portlets and the icons that he needs to see and maneuver with in order to accomplish his job. For example, he has the weather down at the bottom of Dallas, Texas. We are a Texas-based company, by the way. He has an image of a Yardmaster rail traffic icon up there in the top right, a track switch on the middle right, and then system security on the bottom right. So he's monitoring how secure the system is. Is it vulnerable, secure, or breached? And we're going to be using a 1, 2, 3 number to illustrate how that changes. I'm going to actually, I think he's about to log out, and we're going to log in as a different user here. And I'm going to flip back to a policy off of this demo to show you how we actually create the ABAC policies that are showing how this page is built. So this is one policy here it's a special policy called a campaign. And you can see you have the traffic, the secure system, some of those widgets that you're seeing on that page listed in a row. What's going to happen is Interspace, which is our product, is going to intercept his request to that portal. It's going to sit in between where he's clicking and where that server is with the information. And it's going to go down that list and say, should a user like Jim see this image, see this icon, see this widget, see this system security number here? And if yes, then it's going to look at the attributes about Jim and actually personalize the page. So there's kind of a security piece and a personalization piece at the same time because our product does more than one thing. I'm going to log in as a different user now. I'm going to log in as Tony Jones. Tony Jones is an analyst, so his page is going to look a lot different than Jim Russell's. You can see it's the same layout, but he's seeing different portlets, different images. Primarily where I want to draw the attention is down at the bottom, where he has the rail traffic of San Francisco. And he's also looking at a calendar there over on the right and a Dallas Cowboys hat up at the top. What I'm going to do is I'm going to change an attribute about Tony Jones, and you're going to watch how access changes on the page on the fly. And that's really the power of how attribute-based access control works. What's going to happen is if Tony Jones gets relocated, let's say to Chicago, and the HR administrator goes into Active Directory and changes his address, and now here we're going in Chicago and we're changing the zip code. What's going to happen is the second we refresh the page, there's going to be a new request for access, and we're going to change what you're seeing. So now you can see he's looking at Chicago. It's really the power of ABAC. Change in one attribute can change what you see on the screen, or also can change access based on each particular widget, which I mentioned earlier. It's not just an all or nothing access. It's actually pointed at specific resources. The same thing would apply, though, if I were to change an attribute that would apply under that bucket of context attributes. So time of day, threat level, geolocation. This was more of a static attribute. It's one that's being changed within your Active Directory, LDAP directories. But I'm going to flip back over here to Jim Russell up at the top. And remember, he's overseeing the rail traffic. So he's able to flip the track switch icon over there in the bottom, towards the bottom right, where he can switch that track widget left and right. I think I'm about to click there. There you go. You can see it flipping back left and right. And the reason he can do that is we set up a policy that says if the system security is at a certain level, then we'll allow him to do that. But if it's not, we're going to deny him access to that specific widget. I'm going to flip back to the policy here, and what you're seeing, we only have one rule set, but you can see it says system security is greater than a 2. And we're only using 3 numbers for this particular demonstration, 3 being secure. So now I'm going to go back and actually up at the top right, you can see there are 3 different, well, you can't see it very well, but there are 3 buttons, breach, vulnerable, and secure. We set up a mock service that actually we're going to be pulling data from using Interspace to actually populate what's happening on the page. So now it's operation not allowed. What I essentially did, I'm having to talk fast to match the speed of the demo, is I went into a third-party service that we set up and changed the security of the system. So now it's reflecting a change on the page. Furthermore, though, if I actually go up and I change that button again, and not just to vulnerable, but if I change it to breach, we have another policy that's saying access should be completely denied if there's a breach in the system. So what's going to happen is I'm going to look at the third and final policy I'm showing for this demo, and you can see that in order to actually get access to the portal, there are 2 roles, and 2 rules and 1 role that need to be met for this. His role must be a Yardmaster. System security has to be greater than 1. And you can see up there in the top right, it says Yardmaster : access portal. That just kind of encapsulates the policy in one little phrase, the user who's accessing the specific resource. Now you can see he gets denied access to the portal. And again, that's because I actually went in and changed that number by clicking that button up in the top left, changing a context attribute in this circumstance, and then before changing an identity management attribute. And now let's go ahead and flip to the second demonstration. This one's going to be about 4 minutes, I believe. What we're looking at here is I've got the policy up at the top, and then I have information from the database, a screenshot about the users for this demonstration. Up at the top, we have a policy that's saying that the role must be an administrator to access the portal, and then the risk factor is less than 0.5. The model is going to be generating a score between 0 and 1 based on a certain number of inputs that Interspace is going to be feeding into it. Some of those inputs are listed at the bottom. Where is the user located? What's the risk level? What type of employee are they? Are they a contractor or a full-time employee or temporary? We have what device are they accessing it from? How many incidents have they had at work? And so on. And how much have they missed work? It's going to feed those 7 or 8 inputs into the model. It's going to generate a score between 0 and 1. Interspace is going to pull that score back and compare it to the policy and then generate a permit or deny to the portal for a given user. We're going to be looking at Bud Michaels, who's an administrator in this demonstration. He's the third user. We didn't see him before, but his layout of the portal is generally going to be the same as the other users that I showed in the first demonstration. What we're going to do is we're going to look at what happens the first time he logs in, what his risk score is by looking at an evaluation audit. And then we're going to go in and change an input a couple different times to see how his score changes. And then we'll see how access changes at the same time. Here I am. There's the database there. It's difficult to see. That's why we took a screenshot. There's the evaluation audit on the right. I'm going up and I'm authenticating the same way I did in the other demo. Using Bud Michaels, clicking he's the last user. You click OK. And there's Bud Michaels' page. He's overseeing the access records and some of the other widgets on his page, news. And now on the right side, what's happening is we're looking for the green color to look for the risk factor, and it says 0.488. So he matched the policy just with the number of inputs that we provided, initially for the demonstration. But what would happen though if we changed one of those inputs? For example, let's go in and change his missed work time from low to high. What we're going to do is we're going to go actually into the database. We'll change that number or change that value, and we'll apply the change, and we're going to expect a change in the risk factor that's going to be presented back to Interspace. And we're going to actually expect a higher risk score because, as you could imagine, if he's missing more work, it would be riskier to allow him access into the portal. Now he's been denied access. We refresh the page. Why is that? Let's go down and look at the evaluation audit on the right. His risk factor is now 0.6. So it went up based on the change in one input, the change in one attribute. And now let's go ahead and change one more to see what happens. We're going to go back in and change his location. Right now he's actually off-site, but we're going to go and change him to headquarters. So now we're going to expect that risk factor is actually going to lower a bit for some of the obvious reasons. We'll go back and do the same process that we did on the last input. We're going to scroll across, we'll change it from off-site to headquarters. We should expect that number factor to lower just a bit. And when we go back to the page and we refresh up at the top left, now he gets access again. And we can go again and go through the same process and find the number, but you get the idea of what we're doing. A change in one input can change the score, and you see how this integrates with attribute-based access control. This was the idea of what we wanted to show was the power of analytics and fine-grained access control creates a really powerful combination. And this is something we've been developing and something we foresee coming in the market in the coming years as federal and commercial sides begin to adopt technology like this. So thanks so much for coming. We really appreciate it.